November 20th, 1941. A frozen field outside Tula, Russia. The temperature had dropped to -15 degrees Celsius, and the ground crunched beneath the boots of Oberingenieur Klaus Brenner as he approached what would become the most consequential piece of machinery he would ever examine. Steam rose from his breath as he stared at the olive-green monster sitting motionless in the snow, its angular silhouette unlike anything in the German arsenal. This Soviet T-34 medium tank, captured intact after its crew had abandoned it during a failed breakthrough attempt, was about to shatter every assumption the German war machine had made about their enemy's capabilities. What Brenner couldn't have known, as he circled the alien-looking vehicle, was that this single examination would trigger a cascade of revelations that would fundamentally alter the trajectory of World War II. Within hours, his preliminary report would send shockwaves through the highest levels of German command. Within days, it would force a complete reconsideration of German tank doctrine. And within months, it would expose the fatal flaws in Nazi ideology that had convinced an entire nation they were fighting technologically inferior opponents. The story of how German engineers discovered they were losing the war begins not with battlefield defeats or strategic miscalculations, but with a handful of captured tanks that revealed truths too devastating for the Reich to acknowledge. This is the story of how industrial arrogance met engineering reality, and how the most advanced military machine in Europe discovered that their enemies had been building better weapons all along. 6 months earlier, German confidence had reached its absolute peak. Operation Barbarossa had launched on June 22, 1941, with 3.5 million Axis troops streaming across the Soviet border in the largest military invasion in human history. German Panzer divisions had torn through Soviet defences with the same devastating efficiency they had demonstrated in Poland, France, and the Low Countries. The Wehrmacht's tactical brilliance and technological superiority seemed unquestionable, as entire Soviet armies were encircled and destroyed in massive cauldron battles. German tank crews had grown accustomed to facing inferior opponents equipped with obsolete machinery. The standard Soviet tanks encountered during the early weeks of Barbarossa appeared to confirm every Nazi assumption about Bolshevik incompetence. T-26 light tanks, with thin armour and weak guns, fell easily to German anti-tank weapons. BT series fast tanks, while numerous, proved vulnerable to coordinated German attacks. The few heavier Soviet tanks encountered seemed poorly crewed and tactically employed, presenting little challenge to experienced German panzer crews who had perfected their trade across Europe. But scattered reports from the front lines had begun filtering back to German headquarters that didn't match this comfortable narrative. Isolated tank commanders spoke of encountering Soviet machines that seemed to shrug off direct hits from German guns. Anti-tank crews reported shells bouncing harmlessly off sloped armour, unlike anything they had seen before. These accounts were initially dismissed as battlefield confusion or exaggeration from rattled troops facing the stress of their first major campaign in the East. The first concrete evidence that something was seriously wrong came from Oberst Hans Ulrich Rudel's tank regiment during the drive on Moscow. His after-action report, filed in early October 1941, contained details that would have seemed impossible just months earlier. Multiple T-34s had penetrated German defensive positions, destroyed several Panzer IIIs and IVs, and withdrawn without suffering any confirmed kills. German 37mm anti-tank guns, the standard anti-tank weapon of the Wehrmacht, had proven completely ineffective against these new Soviet machines. What made Rudel's report particularly alarming was his description of the T-34's mobility. While German tanks struggled in the increasingly muddy conditions of the Russian autumn, these Soviet machines moved with apparent ease across terrain that would bog down a Panzer IV. Their wide tracks distributed weight more effectively, allowing them to operate in conditions that left German armour formations stranded and vulnerable. The psychological impact on German troops was immediate and profound. Soldiers who had grown accustomed to technological superiority suddenly found themselves facing an enemy whose equipment seemed more advanced than their own. The confidence that had carried German forces across half of Europe began to crack as reports multiplied of impenetrable Soviet tanks appearing like ghosts on the battlefield, destroying German vehicles and vanishing before effective countermeasures could be deployed. General Heinz Guderian, Germany's premier armoured warfare expert and architect of blitzkrieg doctrine, was among the first senior commanders to recognise the magnitude of the problem. His Panzer group had encountered increasing numbers of T-34s during the advance on Moscow, and the tactical situation was becoming untenable. German tank crews were being forced to resort to desperate measures, attempting flank shots at close, in artillery support against individual range or calling tanks. The breaking point came on November 18, 1941, when a single T-34 held up an entire German column for over 6 hours near the town of Veneve. Multiple German tanks had engaged the Soviet machine at various ranges, scoring numerous hits that produced spectacular sparks and ricochets, but no apparent damage. The T-34's 76.2mm gun, meanwhile, had destroyed 2 Panzer III's and a Panzer IV before mechanical problems finally forced its crew to abandon the vehicle. It was this particular T-34, captured intact with minimal battle damage, that would provide German engineers with their first opportunity to conduct a detailed technical analysis of Soviet armour design. The tank was quickly transported to a secure facility behind German lines, where a hastily assembled team of engineers, metallurgists, and weapons experts began what would become one of the most important technical investigations of the war. Oberingenieur Klaus Brenner led the initial examination team that arrived on November 20th. Brenner had spent the previous decade working on German tank development projects and considered himself familiar with the cutting edge of armoured vehicle design. His first impression of the T-34, recorded in his personal notes that evening, captured the shock that would ripple through German technical circles in the coming weeks. The Soviet tank appeared to violate fundamental principles that German engineers had considered immutable laws of tank design. Its sloped frontal armour presented angles that seemed to defy conventional ballistic calculations. The turret design incorporated curves and angles that German draftsmen had never considered practical for mass production. Most disturbing of all, the overall engineering philosophy seemed to prioritize battlefield effectiveness over the manufacturing precision that German industry prized above all else. Brenner's team began their systematic analysis by measuring armor thickness and testing hardness at multiple points across the vehicle's hull and turret. What they discovered challenged every assumption about the relationship between armor weight and protection. The T-34's frontal armor, while nominally 45mm thick, provided protection equivalent to much thicker vertical plates due to its revolutionary sloped design. German 37mm anti-tank guns, effective against 30mm of vertical armour, were powerless against this angled protection. The implications were staggering. Soviet engineers had achieved superior protection using less raw material than German designs required. This wasn't just a tactical advantage, it was an industrial masterstroke that allowed the Soviets to produce more heavily protected tanks while consuming fewer resources per vehicle. The mathematical elegance of the solution was as impressive as its battlefield effectiveness. But the armour was only the beginning of the revelations that would emerge from the captured T-34. The tank's suspension system employed a Christie-type design that provided superior mobility over rough terrain compared to German leaf spring systems. The wide tracks, initially dismissed by German observers as crude and oversized, distributed ground pressure so effectively that the T-34 could operate in conditions where German tanks would become hopelessly mired. Most shocking of all was the discovery of the tank's power plant. The V2 diesel engine represented a fundamental departure from German design philosophy, which favoured gasoline engines for their higher power-to-weight ratios. The Soviet diesel offered advantages that German engineers had never fully considered. Superior fuel efficiency extended operational range, lower fire risk improved crew survivability, and the robust construction could tolerate damage that would disable more sophisticated German engines. The technical investigation continued for 3 days, with additional specialists arriving from Germany to examine specific systems. Each new analysis revealed additional evidence of sophisticated Soviet engineering that contradicted Nazi propaganda about Bolshevik technological inferiority. The transmission, while crude in appearance, proved remarkably reliable and easy to maintain under field conditions. The gun mounting system provided stability and accuracy that matched or exceeded German designs. Perhaps most disturbing to German observers was the evidence of mass production techniques that seemed years ahead of German manufacturing capabilities. The T-34's construction showed signs of automated welding processes, standardized components, and production methods designed for rapid assembly by semi-skilled workers. Soviet industry appeared to have solved problems that German manufacturers were still struggling to address. By November 23rd, preliminary reports were racing through German command channels, reaching the highest levels of the Wehrmacht and Nazi leadership. The technical superiority of Soviet armor was no longer a matter for debate. The question that now faced German planners was how to respond to a technological gap that threatened to undermine the entire basis of German military strategy. The captured T-34 had revealed a truth that would reshape the remainder of World War II. The Soviet Union possessed not just superior tanks, but a superior approach to tank design and production that combined battlefield effectiveness with industrial efficiency. German engineers had discovered they weren't just losing individual battles, they were losing a technological arms race they hadn't even realized they were fighting. The immediate response from German high command revealed the depth of their technological complacency. Within hours of receiving Brenner's preliminary findings, General Oberst Franz Halder, chief of the German General Staff, convened an emergency meeting with representatives from Germany's major tank manufacturers. The transcript of that meeting, discovered in captured German archives after the war, provides a chilling glimpse into the moment when Nazi confidence collided with engineering reality. Ferdinand Porsche, whose company had been developing Germany's next generation of heavy tanks, initially refused to accept the technical assessment. His Tiger I prototype, he argued, would restore German superiority through sheer firepower and armor thickness. But when confronted with the mathematical analysis of the T-34's protection scheme, Porsche's certainty began to crumble. The Soviet tank achieved equivalent protection using 30% less steel, a material efficiency that German heavy tank projects couldn't match even in theory. The crisis deepened when metallurgical analysis revealed the sophistication of Soviet steel production. German experts had long assumed their advanced industrial processes gave them insurmountable advantages in material science. The T-34's armor plates told a different story. Soviet metallurgists had developed heat treatment processes that produced steel with superior hardness characteristics while maintaining workability for mass production. German armor, while precisely manufactured, actually performed worse in ballistic testing, despite consuming more raw materials and requiring longer production times. Dr. Werner Osenberg, director of the Reich Research Council, arrived at the testing facility on November 25th to personally examine the evidence. Osenberg had overseen German weapons development programs since 1937 and considered himself intimately familiar with global technological capabilities. His reaction to the T-34 examination, recorded in his private journal, captured the magnitude of German miscalculation. The Soviet tank represented not just superior individual components, but a fundamentally different approach to military engineering. Where German designers pursued perfection in individual systems, Soviet engineers optimized for overall battlefield effectiveness. The T-34's transmission might be less refined than German equivalents, but its reliability under combat conditions far exceeded anything in the Wehrmacht inventory. The crude-looking suspension outperformed sophisticated German designs when subjected to the brutal realities of Eastern Front terrain. Most alarming was the evidence of Soviet production capacity. Tool marks on the T-34's components revealed manufacturing techniques that prioritized speed and simplicity without sacrificing essential performance. German tank production required skilled craftsmen working with precision tools to achieve acceptable tolerances. Soviet factories appeared capable of producing superior tanks using semi-skilled workers and automated processes that German industry had barely begun to explore. The implications extended far beyond tank warfare. If Soviet engineers could achieve such results in armoured vehicle design, what other German assumptions about enemy capabilities might prove equally false? Intelligence reports from the front lines suddenly took on new significance. Accounts of sophisticated Soviet artillery, advanced aircraft designs, and innovative small arms that had been dismissed as exaggerations now demanded serious reconsideration. General Guderian arrived at the testing facility on November 27th, bringing with him a team of combat veterans who had faced T-34s in battle. Their testimony provided crucial context for the technical findings. The psychological impact of encountering superior enemy equipment was devastating German morale at the unit level. Tank crews who had dominated European battlefields now approached engagements with Soviet armour with genuine fear. Hauptmann Wilhelm Krenius, who commanded a company of Panzer IVs in Guderian's corps, described the tactical nightmare that T-34s created. German tanks were forced to engage at close range where their smaller guns might penetrate Soviet armour, but this negated their traditional advantages in optics and fire control. Soviet tanks could engage German armour at ranges where return fire was ineffective, reversing the tactical balance that had made blitzkrieg possible. The economic implications were equally disturbing. Each T-34 required approximately 8,000 man-hours to produce, compared to 12,000 hours for a Panzer IV that provided inferior protection and firepower. Soviet factories were delivering better tanks, faster and cheaper than German industry could match. The mathematics of attrition warfare suddenly favoured the enemy, a reversal that threatened the fundamental assumptions underlying German strategy. Dr. Heinrich Klauer from the Weapons Testing Office conducted detailed ballistic trials using captured Soviet ammunition. The results shattered another pillar of German confidence. The T-34's 76.2mm gun could penetrate the frontal armour of any German tank at normal combat ranges. German return fire required perfect shot placement at close range to achieve killing hits on Soviet armour. The engagement envelope heavily favoured Soviet crews, who could destroy German tanks while remaining effectively invulnerable to retaliation. The capture of technical manuals from the abandoned T-34 provided even more sobering revelations. Soviet tank crews received training that emphasized mechanical reliability and field maintenance techniques that kept their vehicles operational under conditions that would sideline German tanks. The T-34's design philosophy prioritized maintainability, with major components accessible for repair using basic tools. German tanks required specialized equipment and factory-level expertise for similar maintenance procedures. By December 1st, the technical assessment was complete, and its conclusions were undeniable. The Soviet Union possessed superior tank technology, more efficient production methods, and design philosophies better suited to prolonged warfare. German engineers had discovered they were fighting an enemy whose industrial capabilities exceeded their own in critical areas. The response from Nazi leadership revealed the ideological blindness that would ultimately doom the German war effort. When presented with irrefutable evidence of Soviet technological superiority, Heinrich Himmler suggested that captured German engineers must be working in Soviet factories, explaining away inconvenient facts with racial theories that couldn't accommodate enemy competence. Hermann Göring blamed intelligence failures for not detecting Soviet capabilities earlier, refusing to acknowledge that Nazi ideology had prevented accurate assessment of enemy strengths. Adolf Hitler's reaction, when briefed on the T-34 findings, demonstrated the fatal disconnect between Nazi mythology and military reality. Rather than accepting Soviet engineering achievements, the Führer demanded that German industry immediately develop tanks that would restore technological superiority through overwhelming firepower and armor protection. The Tiger and Panther programs received massive resource allocations, diverting materials and manpower from projects that might have addressed Germany's real strategic vulnerabilities. The German response to the T-34 crisis would prove as revealing as the initial discovery. Instead of adapting Soviet innovations to German manufacturing capabilities, Nazi leadership pursued technological solutions that exacerbated existing problems. The Tiger Y, rushed into production to counter Soviet armor, required twice the resources of a T-34, while providing marginal improvements in battlefield effectiveness. German industry strained to produce small numbers of sophisticated tanks, while Soviet factories churned out thousands of simpler but more effective vehicles. Ferdinand Porsche's competing Tiger design illustrated the German tendency toward over-engineering solutions to straightforward problems. His electric transmission system was a marvel of technical innovation that proved utterly unsuited to battlefield conditions. Complex mechanical systems failed under combat stress, leaving expensive tanks stranded and useless. Soviet engineers had achieved superior results through robust simplicity that German designers dismissed as primitive. The Panther development program, initiated in direct response to T-34 encounters, attempted to incorporate Soviet innovations while maintaining German engineering standards. The result was a tank that combined T-34 armor principles with German precision manufacturing, creating a vehicle that was technically superior to its Soviet counterpart, but required 3 times the production resources and proved mechanically unreliable in service. By early 1942, the strategic implications of the T-34 revelation had become clear to perceptive German commanders. The war in the East would not be the quick campaign that Nazi planners had envisioned. Soviet industrial capacity, demonstrated through superior tank design and production, suggested an enemy capable of sustained resistance that would strain German resources to the breaking point. The captured T-34 had exposed fundamental flaws in German strategic thinking that extended far beyond armoured warfare. Nazi racial ideology had prevented accurate assessment of Soviet capabilities, leading to military plans based on wishful thinking rather than realistic intelligence. German industry, despite its reputation for precision and quality, had fallen behind Soviet mass production techniques that prioritized battlefield effectiveness over manufacturing elegance. Intelligence analysts began reassessing Soviet capabilities across all military domains. If tank design revealed such sophisticated engineering, what other German assumptions about enemy weaknesses might prove equally false? Reports of advanced Soviet aircraft, innovative artillery systems, and effective small arms suddenly demanded serious evaluation rather than dismissive rejection. The psychological impact on German forces continued to mount as T-34 encounters became more frequent during the winter of 1941-42. Tank crews who had dominated European battlefields now approached Soviet armor with genuine apprehension. The confidence that had fueled German victories from Poland to France was eroding under the weight of technological inferiority that no amount of tactical skill could overcome. The T-34 examination had revealed a truth that German leadership was psychologically incapable of accepting. the Soviet Union possessed not just superior tanks, but superior approaches to industrial warfare that combined technical innovation with production efficiency. The captured tank represented evidence of an enemy whose capabilities had been systematically underestimated by Nazi ideology that couldn't acknowledge non-German excellence. As winter deepened around Moscow and German forces struggled with equipment failures in sub-zero temperatures, the lessons of the captured T-34 became increasingly relevant to German survival. Soviet tanks continued operating effectively in conditions that disabled German vehicles, demonstrating the practical advantages of design philosophies that prioritized reliability over sophistication. The stage was set for a technological arms race that would consume German resources while revealing the fundamental contradictions in Nazi ideology. The examination of a single captured tank had exposed strategic vulnerabilities that would ultimately contribute to the Reich's destruction. But German leadership remained committed to solutions that would only compound their existing problems. The full scope of German technological blindness became apparent when additional T-34s were captured and examined throughout December 1941. Each new specimen revealed further evidence of Soviet engineering sophistication that contradicted every assumption about Bolshevik capabilities. The tank showed consistent quality control across different production facilities, indicating a level of industrial coordination that German intelligence had deemed impossible for the supposedly chaotic Soviet system. Dr. Ernst Kneippkamp, Germany's leading tank designer, arrived at the testing facility on December 8th with a team of specialists from the Heereswaffenamt. Kneippkamp had overseen the development of every major German tank design since 1934 and considered himself the foremost authority on armoured vehicle engineering in Europe. His first examination of the T-34's internal systems left him visibly shaken. The Soviet tank's transmission represented a masterclass in practical engineering that challenged fundamental German design principles. While German transmissions required precision manufacturing and skilled maintenance, the T-34's gearbox could be serviced by crew members using basic tools under battlefield conditions. The design sacrificed theoretical efficiency for practical reliability, achieving superior operational availability through robust simplicity. Kneippkamp's detailed measurements revealed the mathematical elegance underlying the T-34's seemingly crude construction. The hull's sloped armour wasn't merely angled for ballistic protection, it was optimised to maximise internal volume while minimising weight and material consumption. Soviet engineers had solved geometric problems that German designers approached through brute force applications of thicker armour and more powerful engines. The tank's welding techniques particularly impressed German metallurgists. Automatic welding processes produced seams stronger than traditional German hand welding methods, while requiring a fraction of the skilled labour. Soviet factories had mechanized complex manufacturing procedures that German industry still performed manually, achieving superior results through technological innovation rather than artisanal craftsmanship. Lieutenant Colonel Hermann Balck, one of Germany's most successful Panzer commanders, provided tactical context that made the technical findings even more disturbing. His regiment had encountered T-34s during the failed assault on Moscow, and the combat reports painted a picture of German tactical doctrine collapsing under technological pressure. The T-34's battlefield performance violated established principles of armoured warfare. German tanks traditionally engaged at maximum effective range, using superior optics and fire control to achieve first-hit kills before enemy guns could respond. The Soviet tank's combination of thick sloped armour and powerful main gun reversed this tactical equation, allowing T-34 crews to close range while shrugging off German fire. Balck's after-action reports documented the psychological toll on German tank crews forced to engage superior enemy equipment. Experienced commanders who had led successful campaigns across Europe now hesitated to engage Soviet armor, knowing their weapons were inadequate for the task. Unit cohesion suffered as crews lost confidence in their equipment and began questioning orders that seemed to guarantee casualties without corresponding tactical gains. The strategic implications became clearer when German intelligence analysts examined T-34 production markings and serial numbers. The tanks came from multiple factories scattered across the Soviet Union, indicating a distributed manufacturing capability that could survive localized disruption. German plans had assumed that capturing key industrial centers would cripple Soviet production, but the evidence suggested a resilient system designed to continue operating under wartime conditions. Factory markings revealed production dates that challenged German assumptions about Soviet industrial capacity. Some captured T-34s bore manufacturing stamps from facilities that supposedly didn't exist according to German intelligence estimates. The Soviet Union had constructed entire tank plants in locations that German planners hadn't identified, suggesting an industrial mobilization far more extensive than Nazi leadership had imagined possible. Dr. Walter Dornberger from the Army Ordnance Office conducted comparative studies between T-34 components and equivalent German systems. His findings revealed a consistent pattern of Soviet engineering that prioritized battlefield effectiveness over manufacturing convenience. Where German designers pursued theoretical perfection, Soviet engineers optimized for practical performance under combat conditions. The T-34's road wheels exemplified this philosophy. German interleaved wheel systems provided superior ride quality and mechanical advantage, but required complex manufacturing and extensive maintenance. Soviet road wheels used simpler technology that was easier to produce and repair, achieving adequate performance through robust design rather than mechanical sophistication. Ammunition storage arrangements showed similar practical intelligence. German tanks carried precisely fitted ammunition that maximized protection but complicated resupply under battlefield conditions. The T-34's ammunition layout sacrificed some ballistic protection for rapid reloading capabilities, allowing crews to maintain higher rates of fire during sustained engagements. The examination of the tank's fire control systems revealed another area where Soviet pragmatism exceeded German theoretical sophistication. While German tanks featured complex optical range-finding equipment, the T-34's simpler systems proved more effective under actual combat conditions. Robust construction survived battlefield abuse that would disable delicate German instruments, maintaining functionality when precision equipment failed. Major General Friedrich von Mellenthin, intelligence chief for Army Group Center, synthesized the technical findings into a strategic assessment that reached the highest levels of German command. His report, classified at the highest security level, painted a picture of technological competition where Germany was falling dangerously behind in critical areas. The Soviet Union possessed superior tank design, more efficient production methods, and industrial capacity that exceeded German estimates by significant margins. Most disturbing was evidence that Soviet technological development was accelerating rather than stagnating, suggesting that German advantages would continue eroding as the war progressed. Mellenthin's analysis identified three critical areas where Soviet superiority threatened German strategic objectives the Red Army to replace. Tank production capacity allowed losses at rates that German industry couldn't match. Design philosophy prioritized battlefield effectiveness over manufacturing elegance, producing weapons better suited to prolonged warfare. Industrial organization demonstrated resilience that could survive the kind of disruption that German strategy relied upon to achieve victory. The response from German industry revealed deep-seated problems that technical solutions couldn't address. Daimler-Benz proposed developing improved armor alloys that would match Soviet protection levels, but metallurgical analysis showed that German steel production lacked the capacity for large-scale implementation. Advanced alloys required raw materials that were increasingly scarce as the war expanded German commitments across multiple fronts. Krupp's engineering team suggested adopting Soviet welding techniques to improve German tank production, but implementation would require retooling entire factory complexes at enormous cost in time and resources. German industry had invested heavily in precision manufacturing equipment that was poorly suited to mass production methods that Soviet success demonstrated. The Weapons Testing Office conducted firing trials that quantified the tactical implications of German technological inferiority. At typical combat ranges, German anti-tank weapons achieved penetration rates below 20% against T-34 armor. Soviet guns firing German-manufactured ammunition showed 70% penetration rates against German tank armor, demonstrating that metallurgical advantages extend protection beyond armor to ammunition effectiveness. Field Marshal Günther von Kluge, commanding Army Group Center, received briefings on the T-34 analysis that fundamentally altered his operational planning. The assumption that German technological superiority would compensate for Soviet numerical advantages no longer held validity. German forces would need to achieve tactical victories through methods that didn't rely on equipment advantages that no longer existed. Kluge's tactical directives reflected the new reality that German commanders faced. Tank engagement should be avoided unless German forces achieved overwhelming numerical superiority or terrain advantages. Anti-tank defense would rely increasingly on artillery and infantry weapons rather than tank versus tank combat, where Soviet equipment held decisive advantages. The psychological impact on German forces intensified as word of the technical assessment spread through military channels. Officers who had built careers on assumptions about German technological supremacy now confronted evidence that their fundamental beliefs were incorrect. The confidence that had sustained German military performance since 1939 began eroding under the weight of technological inferiority. Combat reports from the Eastern Front documented declining German morale as T-34 encounters became routine. Tank crews reported mechanical failures at higher rates, possibly reflecting psychological stress rather than actual equipment problems. Unit commanders noted increased reluctance to engage Soviet armor, with crews seeking excuses to avoid confrontations they expected to lose. The broader implications extended beyond armored warfare to fundamental questions about German strategic planning. If intelligence estimates about Soviet tank capabilities were so dramatically incorrect, what other enemy strengths had been systematically underestimated? Air Force capabilities, artillery systems, and industrial capacity all demanded reassessment in light of the T-34 revelations. Luftwaffe. Intelligence analysts began reviewing their estimates of Soviet aircraft production and performance characteristics. Early dismissals of Soviet aviation as technologically inferior suddenly seemed questionable given the evidence of sophisticated engineering in tank design. German pilots reported encountering Soviet aircraft with performance characteristics that exceeded intelligence estimates, suggesting similar patterns of underestimation across multiple military domains. Artillery specialists examined captured Soviet weapons with new appreciation for enemy capabilities. Anti-tank guns that had been dismissed as crude copies of German designs showed innovative features that improved battlefield effectiveness. Soviet engineers appeared capable of independent technical development that produced solutions German designers hadn't considered. The captured T-34 had become a symbol of German intelligence failure that extended far beyond technical assessment to fundamental strategic miscalculation. Nazi racial ideology had prevented accurate evaluation of Soviet capabilities, leading to military planning based on prejudice rather than objective analysis. The consequences were becoming apparent as German forces struggled with equipment inadequate for the tasks they faced. Dr. Ferdinand Porsche's reaction to the T-34 analysis revealed German leadership the psychological mechanisms that prevents from acknowledging the full scope of their miscalculations. Rather than accepting Soviet engineering excellence, Porsche insisted that captured German specialists must be directing Soviet tank development, explaining away inconvenient evidence through conspiracy theories that preserved ideological assumptions. Similar denial mechanisms operated throughout German leadership, preventing the kind of fundamental reassessment that the T-34 evidence demanded. Each revelation of Soviet capability was explained through exceptional circumstances rather than systematic underestimation, allowing decision-makers to avoid confronting the implications of their strategic errors. The stage was set for technological competition that would consume German resources while revealing the fundamental contradictions between Nazi ideology and military reality. The examination of captured T-34s had exposed weaknesses in German strategic thinking that extended far beyond tank design to encompass intelligence assessment, industrial planning, and the basic assumptions underlying the war effort. As German engineers continued their detailed analysis through the winter of 1941-42, each new discovery reinforced the disturbing conclusion that their enemy possessed technological capabilities that had been systematically underestimated. The Soviet Union wasn't the technologically backward state that Nazi propaganda portrayed, but an industrial power capable of innovations that challenged German supremacy in areas where Reich leadership had assumed permanent advantage. The winter of 1942 brought a cascade of revelations that would fundamentally reshape German understanding of their strategic position. As additional T-34 specimens arrived at testing facilities across the Reich, each examination revealed new layers of Soviet engineering sophistication that contradicted decades of Nazi assumptions about Slavic technological inferiority. The pattern that emerged was more disturbing than isolated instances of superior design. It was evidence of systematic innovation that suggested German industrial philosophy had been fundamentally flawed from the beginning. Oberingenieur Friedrich Vollmer arrived at the Kummersdorf testing facility on January 15, 1942, carrying orders directly from the Reich Ministry of Armaments. Vollmer had spent 15 years developing German tank transmissions and considered himself intimately familiar with the theoretical limits of mechanical engineering. His first encounter with the T-34's transmission system left him questioning everything he thought he knew about automotive design principles. The Soviet gearbox represented a masterpiece of practical engineering that achieved superior battlefield performance through methods German designers had never considered viable, where German transmissions required precision-manufactured components with tolerances measured in hundredths of millimeters. The T-34's transmission achieved comparable performance using parts that could be manufactured on standard industrial equipment. The implications were staggering. Soviet factories could produce tank transmissions using machinery that German industry considered inadequate for civilian automobile production. Vollmer's detailed analysis revealed the mathematical elegance underlying Soviet design philosophy. The T-34's transmission sacrificed theoretical mechanical efficiency for practical reliability, achieving superior operational availability through robust construction that could tolerate manufacturing variations. German systems couldn't survive. Soviet engineers had solved the fundamental tension between precision manufacturing and mass production through innovative approaches that German industry had never explored. The metallurgical investigation conducted by Dr. Heinrich Müller from the Kaiser Wilhelm Institute revealed even more disturbing evidence of Soviet technological advancements. The T-34's armor plates showed evidence of heat treatment processes that produced superior hardness characteristics, while maintaining workability for mass production. German metallurgists had assumed their advanced industrial processes provided insurmountable advantages in material science, but Soviet steel actually outperformed German equivalents in critical ballistic tests. Müller's chemical analysis of Soviet armor composition revealed alloy formulations that achieved superior protection using materials that were more abundant and less expensive than German alternatives. The strategic implications were profound. Soviet industry could produce better armor using resources that were more readily available, providing both tactical and economic advantages that German planners had never anticipated. The examination of the T-34's automotive systems revealed similar patterns of innovative engineering that challenged German assumptions about mechanical design. The Christie suspension system, initially dismissed by German observers as crude and unsophisticated, provided superior mobility over rough terrain while requiring less maintenance than German leaf spring arrangements. Soviet engineers had achieved better battlefield performance through design simplicity that German complexity couldn't match. Tank crews who had faced T-34s in combat provided testimony that made the technical findings even more alarming. Hauptmann Ernst Bachmann, whose company had engaged Soviet armor during the retreat from Moscow, described encounters that violated every principle of German tactical doctrine. The T-34's combination of mobility, protection, and firepower created battlefield scenarios where German forces were systematically outmatched regardless of crew skill or tactical position. Bachmann's combat reports documented the psychological transformation occurring within German armoured units. Crews who had dominated European battlefields now approached Soviet armour with genuine fear, knowing their weapons were inadequate for the engagement. The confidence that had sustained German military performance since 1939 was eroding under repeated encounters with technologically superior enemy equipment. The strategic assessment prepared by Colonel Friedrich von Broich from the General Staff synthesized months of technical investigation into conclusions that reached the highest levels of German command. The Soviet Union possessed not just superior individual weapons, but superior approaches to military-industrial organization that combined technical innovation with production efficiency in ways German industry had never achieved. Von Broich's analysis identified fundamental flaws in German strategic planning that extended far beyond armored warfare. Nazi racial ideology had prevented accurate assessment of Soviet capabilities, leading to operational plans based on wishful thinking rather than realistic intelligence. The assumption that German technological superiority would compensate for Soviet numerical advantages had proven catastrophically incorrect. The response from German tank manufacturers revealed the depth of industrial problems that technical solutions couldn't address. Henschel proposed developing new heavy tank designs that would restore German advantage through overwhelming firepower, but resource analysis showed that such projects would consume materials needed for existing production programs. German industry faced the impossible choice between producing adequate numbers of inferior tanks or small quantities of superior vehicles that couldn't influence battlefield outcomes through sheer scarcity. Porsche's engineering team conducted comparative studies that quantified the production advantages Soviet design and philosophy provided. The T-34 required approximately 60% of the manufacturing resources needed for a comparable German tank, while providing superior battlefield performance. Soviet factories achieved this efficiency through design decisions that prioritized practical effectiveness over theoretical perfection, creating weapons better suited to prolonged industrial warfare. The ammunition analysis conducted by the Weapons Testing Office revealed additional areas where Soviet innovation exceeded German capabilities. The T-34's main gun fired projectiles that achieved superior penetration against German armor, while requiring less sophisticated manufacturing processes than German ammunition. Soviet metallurgists had developed alloy formulations that performed better in combat while consuming fewer strategic materials. Dr. Walter Schreiber from the Army Medical Corps provided insights that illuminated the human factors underlying Soviet technological success. Examination of abandoned T-34s revealed crew stations designed with practical ergonomics that facilitated effective operation under battlefield stress. German tank interiors, while more precisely manufactured, proved less suitable for sustained combat operations, where crew efficiency determined survival. The winter trials conducted at Kummersdorf demonstrated the operational implications of Soviet engineering philosophy. T-34s continued functioning effectively in sub-zero temperatures that disabled German tanks, showing that robust design principles provided practical advantages that sophisticated systems couldn't match. The psychological impact on German test crews was visible as they watched enemy equipment outperform their own vehicles in controlled conditions. Intelligence reports from the Eastern Front documented the expanding scale of Soviet tank production that made German technological responses increasingly irrelevant. Even if German industry could develop tanks superior to the T-34, Soviet factories were producing enemy vehicles at rates that German manufacturing couldn't approach. The mathematics of attrition warfare heavily favored an enemy whose industrial capacity exceeded German estimates by enormous margins. Field Marshal Erich von Manstein's tactical directives reflected the new reality that German commanders confronted. Armoured operations would avoid direct engagement with Soviet tanks whenever possible, relying instead on defensive positions and anti-tank weapons to inflict casualties without risking valuable German equipment. The blitzkrieg doctrine that had dominated European battlefields was becoming impossible to execute against technologically superior enemy forces. The broader implications extended to fundamental questions about German war strategy. If Soviet tank design revealed such sophisticated engineering capabilities, what other enemy strengths had been systematically underestimated? Aircraft development, artillery systems, and industrial capacity all demanded reassessment in light of evidence that Nazi assumptions about Soviet inferiority were comprehensively wrong. Luftwaffe technical intelligence began reviewing their estimates of Soviet aviation capabilities with new skepticism toward previous dismissals of enemy aircraft as technologically backward. Pilot reports of encountering Soviet fighters with performance characteristics exceeding intelligence projections suddenly seemed credible given the pattern of underestimation that T-34 analysis had revealed. Artillery specialists examined captured Soviet weapons with fresh appreciation for design innovations that German engineers had overlooked. Anti-tank guns dismissed as crude copies showed features that improved battlefield effectiveness through practical engineering solutions that theoretical German approaches hadn't considered. The pattern of Soviet innovation appeared consistent across multiple weapons categories. The psychological impact on German military leadership intensified as the scope of intelligence failure became apparent. Officers whose careers had been built on assumptions about German technological supremacy confronted evidence that their fundamental beliefs were incorrect. The confidence that had sustained Wehrmacht performance since 1939 began collapsing under the weight of systematic miscalculation. Nazi ideological responses to the T-34 revelations illustrated the psychological mechanisms that prevented German leadership from acknowledging the full implications of their strategic errors. Rather than accepting Soviet engineering excellence, party officials insisted that captured German specialists must be directing enemy development programs, explaining away inconvenient evidence through conspiracy theories that preserved racial assumptions. Heinrich Himmler's reaction to the technical assessments exemplified this ideological blindness. When presented with irrefutable evidence of Soviet technological superiority, the Reichsführer SS suggested that Jewish scientists working in Soviet laboratories explained enemy capabilities, maintaining Nazi racial theories by denying the possibility of Slavic innovation. Such responses prevented the kind of fundamental reassessment that German survival required. Hermann Göring's analysis of the T-34 crisis focused on intelligence failures rather than strategic miscalculation, blaming information gathering systems for not detecting Soviet capabilities earlier. This approach allowed Nazi leadership to avoid confronting the possibility that their entire understanding of enemy capabilities had been systematically flawed from the beginning of the war. Adolf Hitler's personal reaction to briefings on Soviet tank technology revealed the fatal disconnect between Nazi mythology and military reality. Rather than acknowledging enemy achievements, the Führer demanded that German industry immediately develop weapons that would restore technological superiority through overwhelming firepower and protection. The Tiger and Panther programs received massive resource allocations that would ultimately compound Germany's strategic problems. The German response to Soviet technological superiority illustrated the fundamental contradictions between Nazi ideology and effective military planning. Instead of adapting enemy innovations to German capabilities, Reich leadership pursued technological solutions that exacerbated existing resource constraints while failing to address the root causes of German disadvantage. Ferdinand Porsche's Tiger design program exemplified German tendencies toward over-engineering solutions to straightforward problems. The complex electric transmission system was a marvel of theoretical innovation that proved utterly unsuitable for battlefield conditions. Sophisticated mechanical systems failed under combat stress, leaving expensive tanks stranded when simpler Soviet designs continued operating effectively. The Panther development program attempted to incorporate T-34 innovations while maintaining German engineering standards, creating vehicles that combined Soviet armor principles with German precision manufacturing. The result was tanks that were technically superior to Soviet counterparts, but required 3 times the production resources while proving mechanically unreliable in service conditions. By spring 1942, the strategic implications of the T-34 revelation had become undeniable to perceptive German commanders. The war in the East would not conclude through the rapid victory that Nazi planners had envisioned. Soviet industrial capacity, demonstrated through superior tank design and mass production capabilities, indicated an enemy capable of sustained resistance that would strain German resources beyond their breaking point. The captured T-34 had exposed fundamental flaws in German strategic thinking that extended far beyond armoured warfare to encompass intelligence assessment, industrial organisation, and the basic assumptions underlying Nazi war planning. The examination of Soviet tanks had revealed truths about enemy capabilities that German leadership proved psychologically incapable of accepting, setting the stage for strategic decisions that would ultimately contribute to the Reich's destruction. Intelligence analysts throughout the German military establishment began conducting systematic reviews of enemy capabilities across all domains, seeking to identify other areas where Nazi assumptions might prove as catastrophically incorrect as they had regarding Soviet tank technology. The process revealed patterns of systematic underestimation that suggested German strategic planning had been fundamentally flawed since the beginning of the Eastern Campaign. The T-34 examination had initiated a cascade of revelations that would continue throughout 1942, as each new piece of evidence reinforced the disturbing conclusion that Germany was fighting an enemy whose capabilities had been systematically misjudged. The technological superiority that Nazi ideology claimed as a German birthright was proving to be a dangerous illusion that threatened the survival of the Reich itself. The summer of 1942 brought German engineers face to face with an even more devastating reality as captured T-34s began arriving from multiple fronts simultaneously. Each new specimen told the same story of systematic German miscalculation, but now the evidence was accompanied by production data that revealed the true scope of Soviet industrial achievement. Factory markings indicated manufacturing dates that suggested tank production rates exceeding German estimates by factors of 3 to 4, while serial numbers revealed coordination between facilities that German intelligence had dismissed as impossible under Soviet central planning. Dr. Ernst Heinkel, summoned from his aircraft manufacturing operations to examine T-34 engine technology, arrived at the expanded Kummersdorf facility on June 3rd with expectations shaped by decades of German industrial supremacy. His first inspection of the V2 diesel power plant shattered those assumptions within hours. The Soviet engine achieved superior battlefield performance through design philosophy that prioritized reliability over theoretical efficiency, creating power plants that continued operating under conditions that would destroy more sophisticated German engines. Heinkel's detailed analysis revealed manufacturing techniques that challenged everything German industry considered fundamental to quality production. The V2 cylinder heads showed evidence of casting processes that achieved adequate precision using equipment German factories would consider inadequate for civilian applications. Yet these supposedly crude components outperformed German equivalents in durability testing while requiring fraction of the manufacturing time and skilled labor. The implications extended far beyond individual components to fundamental questions about industrial organization. Soviet factories appeared capable of producing complex mechanical systems using workers with minimal specialized training, achieving quality standards through robust design rather than precision manufacturing. German industry relied heavily on skilled craftsmen whose expertise represented decades of accumulated knowledge, making rapid production expansion impossible without compromising quality. Major General Georg Thomas from the War Economy Office conducted resource analysis that quantified the strategic disadvantages German industrial philosophy created. Each T-34 required approximately 8,000 man-hours to produce, compared to 12,000 hours for a Panzer IV that provided inferior protection and firepower. Soviet factories were delivering better tanks, faster and cheaper than German industry could match, creating mathematical certainties about long-term production capacity that made German victory increasingly unlikely. The metallurgical investigation expanded under Dr. Wilhelm Oehlsen from the Max Planck Institute, whose team conducted comprehensive analysis of Soviet steel production techniques. Their findings revealed alloy formulations that achieved superior ballistic protection using materials more abundant than the strategic metals German armor required. Soviet metallurgists had solved fundamental problems in armor production through innovations that German scientists had never considered viable. Oehlsen's chemical analysis identified heat treatment processes that produced steel with hardness characteristics exceeding German standards while maintaining workability for mass production. The strategic implications were profound. Soviet industry could produce superior armor using readily available materials and simplified manufacturing processes, providing both tactical advantages and economic sustainability that German production methods couldn't match. The examination of T-34 automotive systems revealed similar patterns of innovative engineering that challenged German mechanical design principles. The tank's final drive mechanisms achieved reliability standards that German precision manufacturing couldn't equal, using components that could be serviced by crew members under battlefield conditions. Soviet engineers had prioritized maintainability over theoretical mechanical efficiency, creating systems better suited to prolonged combat operations. Lieutenant Colonel Hermann von Oppeln-Bronichowski, whose regiment had fought Soviet armor during the summer offensive, provided tactical testimony that made the technical findings increasingly ominous. His detailed combat reports documented the psychological transformation occurring throughout German armored forces as crews repeatedly encountered enemy equipment that outperformed their own vehicles in every significant category. Oppel Bronikovsky described engagement scenarios that violated established principles of German tactical doctrine. The T-34's combination of mobility, protection, and firepower created battlefield conditions where German forces were systematically disadvantaged regardless of tactical position or crew experience. Traditional German advantages in optics and fire control became irrelevant when enemy armor could absorb direct hits while delivering devastating return fire. The morale assessment conducted by army psychologists revealed the psychological toll that technological inferiority imposed on German forces. Tank crews reported increased stress reactions and reluctance to engage Soviet armor, with some units showing signs of combat fatigue despite limited actual fighting. The confidence that had sustained German military performance since the beginning of the war was eroding under repeated encounters with superior enemy equipment. Dr. Ferdinand Brandner from the Reich Air Ministry arrived at Kummersdorf on July 18th to examine T-34 components for aircraft applications, but his investigation revealed troubling parallels between Soviet tank and aviation development programs. The manufacturing techniques evident in tank production suggested industrial capabilities that could support sophisticated aircraft development at scales German planners had never considered possible. Brandner's analysis of Soviet welding processes identified automated production methods that could be adapted to aircraft manufacturing, potentially allowing enemy factories to produce military aircraft at rates exceeding German capacity. The implications were strategic rather than merely tactical, suggesting that German assumptions about relative industrial capability were incorrect across multiple military domains. Intelligence reports from the Eastern Front documented expanding encounters with Soviet aircraft whose performance characteristics exceeded previous estimates, lending credibility to concerns about systematic underestimation of enemy aviation capabilities. If Soviet tank development revealed such sophisticated engineering, German assessments of enemy air power demanded similar scrutiny and probable revision. The artillery analysis conducted by Colonel Fritz Hahn identified additional areas where Soviet innovation challenged German technological assumptions. Captured anti-tank guns showed design features that improved battlefield effectiveness through practical engineering solutions German theoretical approaches had overlooked. The pattern of Soviet innovation appeared consistent across all weapons categories examined. Hahn's ballistic testing revealed that Soviet anti-tank weapons achieved superior penetration against German armor using ammunition that required less sophisticated manufacturing than German equivalents. Enemy metallurgists had developed projectile alloys that performed better in combat while consuming fewer strategic materials, providing both tactical advantages and economic sustainability. The strategic assessment prepared by General Franz Halder synthesized months of technical investigation into conclusions that fundamentally challenged German war planning assumptions. The Soviet Union possessed superior weapons design, more efficient production methods, and industrial organization that demonstrated resilience against the kind of disruption German strategy relied upon to achieve victory. Halder's analysis identified three critical areas where Soviet superiority threatened German strategic objectives. Tank production capacity allowed the Red Army to replace losses at rates German industry couldn't approach. Design philosophy prioritized battlefield effectiveness over manufacturing elegance, producing weapons better suited to prolonged warfare. Industrial organization showed adaptability that could survive localized destruction while maintaining overall production capacity. The response from German heavy industry revealed systemic problems that technical solutions couldn't address within reasonable timeframes. Krupp's engineering teams proposed adopting Soviet manufacturing techniques to improve German production efficiency, but implementation would require retooling entire factory complexes at costs that exceeded available resources while the war continued expanding German commitments. The examination of that single T-34 on a frozen field outside Tula had triggered a cascade of revelations that German leadership could never fully accept. What began as routine technical analysis became an autopsy of Nazi ideology itself, revealing the fatal contradictions between racial mythology and industrial reality. The Soviet Union had achieved technological superiority not through captured German expertise or foreign assistance, but through engineering philosophy that prioritized battlefield effectiveness over theoretical perfection. German engineers had discovered they were fighting an enemy whose capabilities exceeded their own in the very areas where Reich propaganda claimed permanent advantage. The war's outcome was already written in the mathematics of production capacity and design efficiency that no amount of German tactical brilliance could overcome.